Hello, my name is Zachary Orr, and this is my paper discussion on accelerating I/O-intensive applications with transparent zero-copy I/O, also known as ZIO. So first, I would like to introduce the problem. The problem centers around the high frequency and the volume of I/O data copies in various modern applications. This occurs at multiple levels within these applications and libraries and in the I/O stack APIs. As we can see from the figure here, it shows various common applications, operations, and I/O copy call site, app, and I/O stacks. In the ANA key value store, a single put request can result in up to 8 data copies, 5 within the application and 3 in the I/O stack, illustrating the inefficiencies in data handling. Now, what is the importance of this problem? The significance of this problem lies in its direct impact on application performance. As I/O operations become faster, the proportion of time spent on the data copying increases, leading to a bottleneck, which is not good. Tests with a Redis server showed that for large objects, a disproportionate amount of the processing time, over 50% actually, was consumed by memory copying, highlighting the inefficiencies and the need for optimization. Now, here is where we talk about the state-of-the-art in-problem solutions. Now, these are already made solutions. So starting off, we have existing solutions like FreeBSD and Solaris, zero-copy APIs, RDMA, NetMap, and memory map files have all attempted to address the issue of excessive data copying. Now, despite their effectiveness in certain scenarios, these solutions often necessitate specific application modifications, which most people do not like. They predominantly fail to address the majority of copies occurring within the application, thus limiting their overall impact and performance and efficiencies. Now, limitations to these current solutions. These current solutions increase code complexity and have limited adaptation due to their non-transparent nature, which requires developers to have specific knowledge and to modify applications accordingly, which can be very time-consuming. These solutions, by not addressing in-application copies, fail to significantly to improve overall performance, as a large proportion of data copying occurs at this level. The new solution ZIO, principle of operation. So, data buffer recording. ZIO starts by recording the original input buffers as data enters the application through I/O operations. This step is crucial for tracking and managing data copies effectively, eliminating redundant copies. Now, lazy execution strategy. Instead of immediately copying data to a new buffer, ZIO employs a lazy execution approach. It defers the actual copying of the data until it's absolutely necessary, such as when a buffer is accessed for modification. Now, handling page faults in user space. ZIO utilizes a kernel feature called userfaultfd to manage page faults efficiently. When an application accesses a buffer that has been marked as unmapped or deferred by ZIO, a page fault will occur. ZIO then handles this fault in a user space, copying the data only when it's accessed. Then, efficient data management. Input to output buffer resolution. When data is written to an output I/O stack, ZIO tries to use this original input buffer instead of the copied or intermediate buffer. This approach significantly reduces the number of unnecessary data copies, tracking across API boundaries. ZIO is capable of tracking data processes, different layers of the application, including API boundaries. This feature is particularly important for integrating with kernel bypass I/O stacks. Now, for interposing on I/O and copy APIs, they use dynamic loading. So ZIO dynamically interposes on I/O operations like read, write, and receive, and memory operations like memcopy and memmove. This allows Zio to manage and optimize data copying without requiring changes to the application code. Now, here's an example of our operation in key value store. So with data flow, we'll consider a key value. We'll consider a key value store where data is read from a network and stored on a disk. As data is read, Zio records the original buffer location. If this buffer is copied to another location, Zio unmaps the destination and updates its tracking, and effectively eliminating the need for a physical data copy. Now, handling modifications. If the data in the buffer is modified, Zio fills in the page fault with data from the original buffer, allowing access while minimizing unnecessary copies. Advantages to this approach. Advantages to this approach are reduction in data copies. Zio does this by managing different copies more effectively. Zio significantly reduces the number of unnecessary data copies, leading to improved performance. Again, advantages of Zio. Zio's transparent approach requiring no application modification sets it apart from previous solutions. It is compatible with existing applications and addresses both an application and I/O stack copies. The comprehensive approach makes Zio a more universally applicable solution, potentially leading to a widespread adoption in various I/O-intensive applications. Zio stands out with its transparent approach, requiring no modifications to existing applications. This compatibility extends both in application and I/O stack copies, making it a very versatile solution. Now, performance improvements. In tests, Zio has demonstrated substantial performance improvements. For instance, in a network echo server test, it achieved up to a 3.2x speedup in I/O throughput. These improvements were also observed in real-world applications like Redis and IceCast, showcasing Zio's practical effectiveness in enhancing I/O operations. In a network echo server test, Zio achieved a remarkable 3.2x speedup in I/O throughput. Real-world applications like Redis and IceCast also demonstrated significant performance enhancements, validating that Zio's practical effectiveness. Feasibility of Zio. Zio's feasibility and effectiveness have been proven in real-world scenarios, showing its compatibility and effectiveness in diverse environments. Zio's integration with kernel bypass I/O stacks and its compatibility to track data across API boundaries showcase its compatibility and broad application potential in diverse computing environments. And thank you for listening to my presentation.